Yeah, so we're looking at today, we are looking at language assessment and some of the assumptions that is underlying machine learning and planners. I mean, it's only 20 minutes, so we're just going in broad strokes about this. I think we want to consider from the very beginning what artificial intelligence approaches there have been to understanding language or processing language, and I will briefly go through what is machine learning and look at the different ways that bias and inequity has been shown to exist as a result of machine learning, and then see how that relates to what we do with language assessments and what are the implications for equity in language testing. So natural language processing is usually a bottom-up kind of language processing. This is in contrast to natural language understanding, which is an approach that is more related to understanding language as a whole first before processing it. That unfortunately has not been the direction in which NLP has proceeded. So currently, as it stands, what we have is this kind of bottom-up language processing. A critic of NLP has called it kind of a knowledge lean text string manipulation. And there is an element of truth in that, as we will see later. But some of the Python libraries that we can use now are Natural Language Toolkit and GenSim, which perhaps some of the audience might be familiar with. So we see here a lot of natural language processing, machine learning have overlaps, and NLU is somewhat in the periphery, but of course still embedded within the whole artificial intelligence movement. So the basis of a lot of machine learning is the neural networks. I won't go too much into detail, but just so that we understand where this is from. So basically we have inputs, language, words or parts of speech, depending on how you parse the what inputs you're going to put in and what you're looking at. So we have the inputs and then the relative weights that is assigned to those inputs, which then goes through a transfer function. And then we have the activation function, which defines the output of a node given the input that we have and converting it from infinity to minus infinity to a more limited range of values. And then finally, you have the output, where be it classification or production in the case of, say, chatbots. So these may be analogous to independent variables and dependent variables, if that's how we want to look at it. So there's several types of neural networks that we use. Most of them are feed-forward neural networks or the multi-layer perceptrons, which is basically just feeding forward the inputs, and then you have a single output. While in contrast, if you have the recurrent neural networks, for example, which is more of a feedback loop. So what you have is the outputs that feeds back and updates the weights. A type of feed-forward neural network is a convolution neural network. So a lot of this is based on linear algebra, matrix multiplication. And what happens is that, sorry, let me just go back. It represents words as part of a matrix, and then there's stuff to it. So we won't go into detail, but machine learning software, click-and-go machine learning software has been used to do a lot of, increasingly, a lot of the statistical analysis for language testing in particular. So we have regression, classification, and clustering, and it really harnesses the power to compute larger samples of data. So
if I may add one point here, Azrifah, do you hear me?
Mm-hmm.
You hear me fine? Okay. and there's construction work going on outside of my window. I can't hear myself. I hope you can hear me. So yeah, as Azrifah said, there are software packages that can allow us to do basic types of machine learning, but I see that increasingly there are new and more exciting developments in this field. For example, JASP is a development, as you see here, and it allows us to use a number of machine learning capabilities. But if you are more adventurous and you want to try more sophisticated sort of machine learning techniques and analysis, I think it would be more suitable to think about using a programming language like Python or other languages like R, etc.
Okay. Sorry. So there have been some recognition that there has been bias and inequity in machine learning. It's a rather well-known study about how skin tone and facial recognition, that there's a very high error rate between the lighter male faces and the darker female faces and how they're classified, as you can see here. And also for us, in terms of language, what would be relevant is how recognition of different varieties of English, in this case, African-American English, has been misclassified in some of the tweets well, as compared to the white aligned tweets. This is a quotation from the actual study. So one of the ways in which language has been processed is sentiment analysis using supervised machine learning, where meaning is ascribed through manual annotation, and then alternatively, the rule-based approaches have also been used on annotated data with the associated sentiment features or measures, and these are classified using the neural networks on the basis of a set number of categories. So it really limits the range of meanings and features that can be ascribed. So that in one of the studies that we have looked at, for example, when predicting anger, joy, or vehemence, the number of systems consistently give higher scores to sentences with female noun phrases, much higher than the number of systems giving higher scores to sentences with male noun phrases, kind of buying into this idea of women are more emotional, that kind of stereotype. So it does repeat some of the stereotypes that we have in society. So as previously mentioned, a key principle in machine learning is using the geometric cosine to measure the degree of agreement between vectors of bags of words. So each word in a piece of text, or here they call it document, is represented in a matrix. And this matrix is usually compared to the matrices are compared to each other on the basis of the geometric cosine on the vector space. So the similarity between two texts, for example, would be the cosine, the angle of agreement between the two vectors, basically. So this has been used rather extensively for content analysis and to a certain extent for automated short answer marking. And some of the drawbacks of this approach has been that it ignores linguistic structure and meaning, so that bottom-up kind of processing actually ignores the larger cohesive structure of texts. And it also doesn't account for the distribution of words, which, as we know, is inversely related by frequency and rank. So LSA, on the other hand, assumes normal distribution, which does not occur for words. Another technique is word embedding, as previously mentioned, where words are represented as points in a vector space. From the frequency of co-occurrence in a corpus, for example, relationships between words can be established. One of a very popular model is the word to back. And it has shown, for example, that if you put in king to man, if you ask for woman, you probably get queen. So there's some applications to test design that is rather recent, as you can see here, a recent study by Settles et al. In 2020, and for the Duolingo computer adaptive language test. So they use two training sets for a few types of items, but basically one is for the vocabulary scale and the other for the passage scale. And what is interesting is that there is indeed a strong positive correlation with expert human judgments for the vocabulary scale. However, in comparison, the passage scale is very much, is not as strongly positively related with the CEFR assigned labels by the human judges. Sorry. No. Oh, okay. So another study attempts to generate MCQ reading comprehension distractors using the RACE dataset as a training set, and which is a large-scale reading comprehension dataset collected from English examinations in China, designed for middle school and high school students, and a related study in So and all, the same dataset processed by Gao et al. So it's just a follow-up studies. And so what is interesting here is how they actually use capability to confuse annotators as a performance of model judgment. As model judgment for the performance of the model itself. So it's not how reliable or how valid the distractors are, but how confusing it was to the annotators. So this calls to mind the question of whether there's machine learning generated items actually underrepresent certain constructs. So for example, in a study and by Aryadoust and Go, we have mid to high accuracy, but we have high construct representativeness. Well, you know, for Settles et al. And Gao, you have high accuracy but low construct representativeness. So as we have seen with the Settles study, the models perform very well for kind of like word level test items, but items for integration of comprehension text is very much an area that needs to be addressed. So the question then becomes, is it just a mirror for our society? Is it our biases that just reflected on that? So one of the studies have shown that the primary embedding for the popular publicly available Word2Vec that I mentioned before, trained on a corpus of Google News text, so you know it's very much our societal text, has shown that if you have she, it tends to be mapped to homemaker, nurse, receptionist, librarian, socialite, while he is, you know, mapped to maestro, skipper, protege, philosopher, captain. So we might argue that it's a mirror to our own biases. So that's a question that we might have to answer for ourselves, whether machine learning is just highlighting the ways that we use language, or is there something that we can do about it when we actually want to use machine learning models to generate tests. So we have to consider, among other things, the sources of the language training data that we use. You know, and also the kind of genres and the varieties of languages that we have sampled. Like, for example, the study on African American English being misclassified is a perfect example of how varieties of languages sampled can have an impact on your model. And then once we move on to grading, we have to question whether you know, students are graded merely on surface level constructions. You know, if we train our models on surface level constructions, are they then graded on only that? And what is then the role of coherence or content in, you know, in our tests? and it's not quite helped by the rather as understandable reasons for proprietary systems not to be transparent, but the lack of transparency also calls into question, you know, some of the implications for equity. Sorry. Okay. So as we have also previously mentioned, there are some questions about validity and of construct underrepresentativeness if we just use surface levels constructions or bottom-up processing for NLP to generate test items. And also if we want to think about test design for learning, what is the role of the learner in or the test in developing learner autonomy, sorry. So, so for example, Huang and Punana has found that meta-language used for corrections in an automated feedback system is not comprehensible to learners. And of course, then the question is, if they don't understand the feedback, how then can they develop their own autonomy to learn further and develop? So I think that's pretty much all that we have. So thank you very much.